M76 circumference activity. All right, so this is an interesting thing that I'll try to show you as best I can on video. Right, but this is an activity that if you want, you can do at home. They're usually not something that we usually have time for in class because it takes a little bit of time, but sometimes we do it in math lab if we have that attached to this course. So just sit tight and I'm going to show you some interesting things about diameters and circumferences in circles. Okay, so we have gathered a red lid and an aluminum lid. So we are going to measure the approximate diameter because I can't find the exact center, right? And I'm going to do this in centimeters because they're a slightly more accurate measurement. And that you're going to get a bit of a glare, but that's okay because I can still see it. All right, so if I go to the approximate, fun fact, if you're trying to do this at home, the diameter will always be the largest measurement that you get when you're measuring the circle from end to end. So if I need to approximate the center, all I have to do is hold my ruler on one side of the circle and then slide it until I get the largest possible measurement. So let's see here. It looks like the largest measurement I'm gonna get is right around there. We'll say that's it looks like about 10.8 centimeters. Yeah. So this is the smaller one, diameter, we'll say 10.8 centimeters, right? So we're recording this, and then we'll do the diameter of the red lid. Okay, so I'm going to pin that right there with my thumb, rotate this here. Oh, it looks like 16 centimeters is going to be the diameter for the red lid. Now some of you may be wondering, Mr. Claiborne, how in the world are we going to find the circumference? There's two ways we can do this actually. The first method is we could take a cord, right? Normally you'd want to use a string, but I'm limited for materials in my classroom. You take a cord and you would wrap it around the circle. Whoop. Attempting to keep it as tight as possible. Right, and once you wrap it around, kind of like a tape measure, you would mark where it starts and ends. Right, so right there, that point on my thumb is one circumference. Right, and once I've got that point marked, I stretch it out again, and I measure it on my ruler. So if I stretch that out and I measure it on the ruler, oh, that gives me longer than what my ruler can measure. So let's see here, that goes to 45, and then it looks like we're at 50.3, we'll say 50.3 centimeters for the circumference of the red one. And, oh no, I put that in the wrong spot. Okay, that was supposed to be 16 centimeters. This is 50.3. Okay? Now let's do the same thing for the stroopwafel can. The other way, and this is less accurate. Well, actually, I guess it depends on how accurate you are as a person. Right? We could mark one spot. So we mark one spot on our lid, so that's going to be my starting and end point, and I'll set 0 right there, and then I will just roll my lid along my ruler until I get back to that starting point. Now again, you really determine how accurate or inaccurate this is, but this method is a little bit harder to pull off than the cord, and you can see I'm kind of wobbling up and down, so the up and down wobble can lead to inaccuracy. So doing that method, I get 31.2. Let's see here, 0.2. Let's see how long I get if I use the cord and see which one is a little more accurate. So if I wrap the cord around, Whoop. I'm going to stretch this out, and I get 33.6 that time. Alright, so it seems like the chord is more accurate than wrapping the ruler. Alright, now once we found both these numbers, I'm going to use the magic of the calculator to find what we would call the ratio between the circumference and the diameter. The way we do that is we take the circumference, we divide it by the diameter. So for the big red one, I'm going to take 50.3. We're going to see something really interesting here. I take 50.3, I divide it by the diameter of 1/6, and I get 3.14375. We'll round that to the hundredths place, which will just make it 3.14. So this is approximately 3.14. That's what the ratio is. Let's do the same thing with this one. Let's take 33.6, we'll divide it by 10.8, and okay, here if I round this in the hundredths place, I get 3.11. Right, so that's approximately 3.11. All right, now with this one, I know I made some errors because it should be a little longer than that. So I'm going to measure this again and see what happens. All right, because both of those numbers aren't great. What should happen is I should get about 3.14 again. And you should already notice these numbers are really, really close. And you know, I just realized what the issue is. I measured on the outside rim, whereas my chord is wrapping closer than the outside rim. So let's try this one more time. Let's see if I can get my chord to, you know, actually maybe I should just measure a new diameter. Here. Okay, yeah, I still get about 33.6, so I just need to remeasure my diameter from the inside, not the outside rim. So my diameter was off. Whoops. Let's try this again. It looks like I'm getting about 10 centimeters, so I'll try 10 centimeters, the new adjusted numbers. So now if I take 33.6 divided by 10, well that's a little too big. Well, we're floating right around just above and just below 3.14. What if I did, what if it was, interesting. Okay. Well, the point of this lesson is that every single circle, the diameter and the circumference, they have the exact same ratio. And if we account for errors in measuring, which I'm making on this blue can because it's a little bit smaller and harder to measure, we end up with the same ratio, and that ratio is going to be 3.14 every single time. So that's the fun activity for the circumference. And on your homework, you're going to have questions where they'll ask you, you know, hey, if the diameter is 10 centimeters, what's the approximate value of the circumference? And the way that you would find that is you just take the diameter, multiply it by 3, and say that it would be slightly bigger than that number. So I would take the diameter 10, multiply it by 3, get the number 30, and my answer would be that you would actually write on your homework on test is the circumference is slightly bigger than 30, right? Or here, if it was 16, I multiply 16 by 3, and that ends up being 48, and you could write down the answer is slightly bigger than 48. And then vice versa, you could also divide by 3, and then say the answer is slightly bigger than whatever that division number is, or slightly smaller. That's it for this lesson. You know, there's not any practice problems on this lesson, and problem 30 is the one that relates to it. There's only one problem in the lesson about this lesson, but it's more of a knowledge video than it is a how to solve video. If you guys have any questions, let me know on the school website, and I'll see you in class.